Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's the problem for today for exam FM. It's from Spring 2003 Casualty Actuarial Society Course 8 examination, so it's a little bit more advanced, but it's a problem on swaps, and swaps are a part of the material on exam FM. An 80 million interest rate swap has a remaining life of 15 months. Under the terms of the swap, 6-month LIBOR is exchanged for 10% per annum, compounded semi-annually. LIBOR rates with continuous compounding have been the same for the past 3 months and are shown by maturity below. For 3 months, it's 8%. All of this is continuous compounding, so these are forces of interest. 6 months, 8.25%. 9 months, 8.50%. 12 months, 8.75%. And 15 months, 9%. Calculate the current value of the swap to the party paying floating rates, so the party short the swap. Assume that the floating payment and the applicable rate is made at the end of the period for which the floating rate is calculated, and that both sides' payments are made every 6 months. So the settlement is in arrears. You look back for the interest rate that you use, the floating rate that you use, as a LIBOR rate that you use for the calculation of the floating side payment. First, there are, so here's the solution. And first we note that there are 15 months remaining in the swap, and payments are made every 6 months, so they will be made 15 months from now at the end of the swap, at maturity of it, and 6 months earlier, which is 9 months from now, and then 6 months earlier, which is 3 months from now. The payments and their value will be as follows. In 3 months, the pay fixed side will pay 5% of 80 million, so $4 million, while pay floating side will pay 6-month LIBOR for the period from 3 months ago to 3 months in the future. And since we know that rate to had been 8.25% continuously compounded, because we are told that the rates remain the same the last 3 months, we know that the floating side payment will be, well, it's a continuously compounded interest rate. So normally you would just multiply the interest rate I by the notional amount, but you can't. Instead, you calculate what 1 plus I is, and 1 plus I is equal to e to the delta. Now, this is delta over half a year, so it's e to the delta times 0.5, but still, that delta, the force of interest, or continuously compounded rate, is 8.25%, so it's e to the 0.0825 times 1/2 minus 1, and of course that becomes the interest rate, the effective interest rate over that period, times $80 million notional principal, and that's $3,369,809. And of course the actual payment made will be the net of the two. And since the fixed side pays $4 million and the floating side pays this, the net will be $630,991.91 paid by the pay fixed side, received by the pay floating side. So it's a positive value to the side that is short this swap. And we are calculating this for that party, which is short the swap. Now, in 9 months, the pay fixed side will pay, again, fixed payment, 5% of 80 million. That's the effective rate over half a year on the pay fixed side. While the floating side payment will be determined from the 6 months LIBOR for the period from 3 months from now till 9 months from now, which right now is represented by the forward rate between 3 months from now and 9 months from now, calculated as the effective semi-annual rate from 3-month and 9-month current spot LIBOR rate. So remember that 1 plus the forward rate for that period times 1 plus the spot rate to the beginning of the period equals, and then taken to appropriate power in terms of time, is equal to 1 plus the spot rate taken to appropriate power over the entire period. So what I just said is that 1 plus the forward rate that we're trying to calculate will be equal to, multiplied by, e to the 0.08 times 0.25, which is the accumulation factor until the beginning of that period over which we are looking at the forward rate. That will be equal to e to the 0.085 times 0.75, which is effectively 1 plus the spot rate effective over the period from now until the end of the period over which we're calculating the forward rate. So what we have is e to the rate we're looking for, the forward rate, and it's effective over those 6 months. It's not annualized rate. Is e to the 0.085 times 0.75 divided by e to the 0.08 times 0.25 minus 1, and that's approximately 4.472114%. So the floating side payment will be that interest rate times 80 million, which is 3,577,691.36, and the actual cash flow will be the net payment of the difference of the two, which is 422,308.44, and it's made by the pay fixed side, received by this party that is short the swap. So again, it's the positive value to the party for which we are calculating the value of the swap. Finally, in 15 months, the pay fixed side will pay 5% of 80 million, so 4 million, while the floating side payment will be determined from the 6-month LIBOR for the period from 9 months from now till 15 months from now, which right now is represented by the forward rate between 9 months from now and 15 months from now, calculated as the effective semi-annual rate from 3 months and 9-month current spot LIBOR rates, just like before. So the 9-month spot LIBOR continuously compounded is 9%. So we have e to the 0.09 times 1.25 divided by e to the 0.085, the effective continuously compounded LIBOR over for the point in time 0.75 years from now. So times 0.75 minus 1, and that comes out to be 4.995783%. Hence, the floating side payment will be approximately that percentage times 80 million, and that's 3,996,626.28. And the actual net cash flow is the difference of the two, which is 3,373.72, made by the pay fixed side. In 15 months, of course, there's also 80 million principal on both sides, but since it's an identical payment, no principal exchange is necessary, and even if it were done, it would be irrelevant. If I give you $80 million and you give me $80 million, the net payment is zero. So why are we doing this? Finally, the value of the pay floating side is the present value of the 3 net payments that the floating side will receive, and we can calculate the total present value using the spot LIBOR rates given. So the first is divided by e to the 0.08 times 0.25, the second one by e to the 0.085 times 0.75, and the third one by e to the 0.09 times 1.25, and that comes out to be 1,017,738.85. Now, let me note also that an alternative approach would be to point out that in 3 months, the floating payments will refer to 80 million principal at the then market value of LIBOR, so the principal amount of 80 million will be worth 80 million in terms of market value. Therefore, we can calculate the value of the payments made by pay floating side, including principal, as the value of the first interest payment in 3 months, plus the value of principal paid at that time, 3 months from now. The next floating payment is the interest due on 80 million, at 6-month LIBOR from 3 months ago, identical to the current LIBOR of 8.25 compounded continuously. Therefore, that amount of interest paid in 3 months is, as we calculated before, 3,369.08.09. Together with the 80 million principal, the current value of the floating side payments is 81,718,191.10. The remaining fixed side payments are 0.05 times 80 million, so 4 million in 3 months, 9 months, and 15 months, plus the repayment of principal of 80 million in 15 months, and have the present value of, we just calculate the present value of all those payments, 82,735,930. The value of the swap to the party paying floating and receiving fixed is the difference of the two, and it's equal approximately to 1,017,738.85, and it's answer E either way. Please remember this is copyrighted material. The problem itself belongs to the Casualty Actuarial Society, is reproduced with permission. The solution is mine. Good luck in your studies and good luck on the test.